So, good afternoon, dear LinkedIn community and composites experts out there. Today I'm at Engenuity, like we said yesterday and teased with Tim Hall, the commercial director. He allowed me to have a visit at their Burgess Hill facilities, and with me together is Miles Price. He's the laboratory manager here at Engenuity, and he walks me around, and we've already taken some picture that we will now use as a B-roll while we are talking. Very, very fantastic laboratory here. Thanks, Miles, for having me.
Thank you for coming to visit us today.
So you see in the backdrop, let's start with this one. This is a very spontaneous idea to get you some exposure of things that are happening in the real life. We're always talking about computer-aided engineering, simulation and things like that, but it's always, of course, interesting to see what's happening. So what is this bike? What were your contributions to this bike, Miles?
So this bike is a GoCycle folding electric bicycle. It has batteries in the frame that power the motors in the wheels, and it can be folded up. So Engenuity worked on this project a number of years ago with the manufacturer, and we analysed the wheels and the frame, and we supported the engineering development. This is a lightweight bicycle, and it's designed for commuters, and the parts are made out of magnesium alloy. So this is just an example of one of the projects where we've worked on to support the engineering development through materials testing and engineering analysis.
So this bike gives us a good idea about already what the difference is between a classic research lab and Engenuity. Can you elaborate a bit on this, Miles? What are the concrete differences? What differentiates you from research labs?
Yeah, absolutely. So one of the differences between Engenuity and other research labs is we've developed over the number of the last few years our in-house materials testing laboratory for composites, for metals, for other types of plastics, sandwich materials, adhesives, and other fastening and joining methods. All of the materials testing to characterize the materials is in-house, in the same building and with the same team as the engineering analysts and the engineering development team. So we have a really close-fitting, joined-up process where we go from the materials selection, design. We can run materials screenings to choose the correct material for the application. And once we have completed all of the materials tests for this application, and that can range from all of the basic tension, compression, shear, up until some of the more complex material properties like fracture energy release, impact testing, energy absorption, fiber volume content of the materials. Once we have completed all of those testing, we work closely with the engineering development teams and analysts at Engenuity to optimize the design and make sure that the components and the structures are ready for manufacture. And that all happens under one roof by one technical team. So we're very closely linked, the two departments, and we can accelerate the development into a shorter time scale with the same number of people to meet the cost and timings that are necessary for industry at the moment. Hopefully that's a broad overview of what Engenuity does and how we have developed ourselves to support industry for the demands that are relevant today.
So Miles, thanks for the application with the bike, and now we are at the laboratory and we are seeing here nice machines, and yeah, fill us in. What typical tests are you conducting here at Engenuity?
Sure. So at Engenuity we conduct all sorts of types of tests on fiber reinforced composites, adhesives, sandwich materials, fastener methods, bonding and jointing, as well as some metals as well. The tests that we undertake here cover a range of different test rates, from static, dynamic, elevated temperature, so hot, and also lower temperatures like cold testing as well. one of our climatic chambers where we can control the temperature between 350 degrees Celsius and minus 70 degrees Celsius. And some of the types of tests we do range from the basic tests such as tension and compression and shear, up to some of the more complex tests such as energy absorption, fracture energy release rate, dynamic impact, and other tests like that as well. So some of the types of industries that we work with are around motorsport, Formula One, automotive, and others such as marine, wind energy.
We need some wind here because it's one of the hotter seasons here in the UK.
It is.
And we feel it also here in the laboratory,
nice
right?
Warm one today. Yeah, absolutely. It's the summer.
Yeah, what's the strong link between your testing lab and your engineering analysis team?
So we're actually in the same building.
Right.
So Engenuity it has the key advantage of having the materials testing facility and the team of engineering analysis and the analysis support team all in the same building. So if we're having some difficulties with a test where a material is either really good in one property or really poor in another property, then this can cause some difficulties for using the material and analysing the material later on. So this is one of the things that can be quite difficult to navigate if we're writing test reports, and can cause problems later on for the engineering development. So we can actually have a very quick meeting, a huddle around the machine with the engineering teams to look at the test results and come up with a way forward that allows us to streamline the process and get back to what we're doing best.
Great. This morning I was in Milton Keynes, the MK Dons, the football stadium, and it's attached together with a hotel. And the hotel had boardrooms called strategy, analysis, and performance. Now that reminds me basically to a football game where they have the strategy set up. That's done by your engineering team. You do the analysis.
That's right.
And now the third pillar is performance. So do you track the performance then also on site with your customers in applications?
The best thing to happen is where the customer comes and speak to us at the beginning of the process, before they've started to choose their material, to finalize the design. So we can have a look at the design to see if there's any concerns that we have.
Right.
And some of the projects that we get involved with are at a later stage where there might be some problems with the material, there might be some problems with the design, and we have to go back a few steps.
And do some iteration?
That's right.
Is that the ideal situation?
The ideal situation is right first time every time. And that's one of the things that we like, is when the customer on the project starts to talk to us early on in the stages, so we can get this right first time around. And that starts right at the beginning with the Engenuity method, which is select your material, characterize the material, and then we can prototype for the first time round and test, rather than make a few prototypes, test a few, and then go back to the drawing board later on. What we have here is the Instron 8802 machine that we have here at Engenuity at our HQ in West Sussex. This is one of our largest universal test machines, and it has a capacity of 250 kilonewtons. So this is the dynamic load cell that we have here. And we also have the capability to use lower load cells as well, such as a 10 kilonewton load cell. Some of the testing that we're doing on this machine this week can be either quasi-static testing, so very slow, or we can do dynamic and fatigue testing here as well. So some of the tests that we've been covering have been fatigue testing of fibre reinforced composites to look at how the material behaves when it's continuously cycled throughout the lifetime of the part. As the name suggests, it's a universal test machine, so we can take out the fixture that's in there at the moment and we can input another fixture to do different types of testing: tension, compression, shear, and other interlaminar strength testing. If we have a look at our shelf of fixtures over here, some of the fixtures that we have available on our shelf today, we have the ASTM D7078 V-notched shear fixture. We have the ASTM D6671 mixed mode bending fixture, the ASTM D6641 combined loading compression fixture, and the ISO 19927 interlaminar shear fixture by 5-point bending. Some of the other fixtures are in the background in their wooden boxes, but I'll leave that to your imagination. So this is the first stage of the Engenuity lab. This is our materials inwards processing. and this is where the materials, first of all, will be inspected for any defects. We'll measure the dimensions, and then we'll create the nesting profile that the specimens will be printed onto the surface of the specimen. This is our specimen printer, where we'll print onto the surface of the material any machining lines, any specimen labels, QR codes, and any speckle pattern that we have. So these black and white dots that are on the surface of the material are printed on the front and the back of each specimen where we need to measure strain. And these are used where we need to measure strain on the surface of the materials instead of using strain gauges. This is an intermediate drop weight tester, where we've been doing some sandwich panel and monolithic laminate testing, where we drop an indented striker